One of the most basic troubleshooting commands for every network is the ping command. This allows us to check for basic connectivity and reachability over the network. If I'm troubleshooting a network, this is quite frequently the first place I'll start. This is going to tell me if I'm dealing with a physical layer issue, something maybe like a broken or unplugged cable, or if there's a more advanced issue, something like access control lists or routing protocol problems, and so on. Here I have a very simple topology. I only have two routers, and those are connected to one another. If I want to check for basic layer 2 connectivity between those routers, I can use the command ping followed by the IP address that I'm trying to reach. In my case, that's 10.1.1.2. That's the IP address for router 2. If I hit enter, you can see that the results of that ping command are successful. I'm told that the success rate is 100%. 5 out of 5 messages were sent and responded to. You can also see it stated that this uses ICMP, the Internet Control Message Protocol. This is a layer 3 protocol that sends out an ICMP echo. By default here, we see that those are 100 bytes each. So again, 100 byte echo requests being sent out, and there were 5 of those sent to the 10.1.1.2 IP address. If this had been a failure, we would know that something was wrong, most likely at a lower level. Common issues would be cabling issues, of course, but it might also be the port interface being shut down on our router or on the remote router. But in this case, we don't have any problems indicated. We can see 5 exclamation points in the results. So that indicates that all 5 of those pings were successful. Now you'll also want to note that often when you ping a host for the very first time, it's not uncommon to see that very first attempt fail. So instead of 5 exclamations, you might see a decimal followed by 4 exclamations, and then you would get an 80% success rate the very first time you try to ping an IP address. And that's because the remote router has to put the ping request on hold in order to send out an ARP broadcast so that the MAC address of the device that you're pinging from can be learned. So in our case, router 1 would send out an ICMP echo. Router 2 would respond to that with an ARP broadcast in order to learn the MAC address of this device, and then it would be able to respond to subsequent pings. And that often takes more than the allotted 2-second timeout. We see listed here that the default setting is timeout of 2 seconds. So after 2 seconds, an ICMP echo is regarded as being timed out or failed. And that's why you'll often see that very first attempt fail. If you follow that up with another ping immediately, you should see a 100% success rate as we see here. Other things that we can glean from this information is the round trip time taken for those ping messages. You can see those stats listed here in milliseconds. We have the minimum, the average, and the maximum as 6, 8, and 15 milliseconds. If there was an ICMP failure, as we've already mentioned, those are indicated in iOS with decimals or with dots. So let me ping a non-existent IP address on my network. I'll say 10.1.1.10. That doesn't exist here, so I'm definitely going to get a failure. And you'll be able to see that the output is going to show 5 decimals. Each one of those 5 attempts is met with a failure, and we'll be told at the end, there we see it, that our success rate is 0%, 0 out of 5 messages. So this would indicate some sort of lower level issue. If we say ping 10.1.1.2 and look at our contextual help, you can see all of our other options available to us with the ping command. Another very common way that I'll use this is with the keyword repeat, followed by a really large number. And that's going to give me a sort of continuous ping. If I hit enter, you'll see that's just going to continue to reach out to that remote device. And you can break out of that command with the Control-Shift-6 key combination if you need to do that. I'll often use this if I need to reboot a remote device. I like to do that in order to see when the device comes back up. If I set a continuous ping, let's say to router 2 in this case, and then I rebooted router 2, instead of this series of all successes that we see listed with exclamation points, in the middle of that you would see some decimals in the output indicating failures while the device was in the rebooting process. And then when it came back online and the interface was available again, it would move back to showing the exclamation points for successes. So that's just a common way that I like to do that if I'm rebooting a remote device, just to keep an eye on things. Now we can also set the size of the ICMP packet manually by saying ping 10.1.1.2 followed by the size keyword. And you can see with our help command, we're shown a range that we're able to set that datagram, and those are in bytes. So commonly we might say something like 1500 here. Let's say we're testing out some sort of quality of service policy that we have in place on router 2 that might be limiting certain packet sizes. Or let's say we're testing out the MTU size of the remote interface. If router 2's interface had an MTU size set to, let's say, 1400, then these pings would fail and we would know that there was some sort of MTU mismatch. Another option is to use the source keyword. Now, by default, when we're pinging, whichever outbound interface that I'm using to send the ping out of will be the source address. In my case, that traffic is going out of gig 0/1. Let's say I have another subnet on my router connected to gig 0/2. I can force the router to use a source address using this command from the subnet on my gig 0/2 interface. And if I hit enter, we will see that fail. And the failure here lets me know that somewhere in the path, there's a device that doesn't know how to get back to the subnet on my gig 0/2 interface. Now, in my case, I don't have any routing protocol set up between those subnets, so that's definitely the issue. But if we were on a normal network and we knew we could ping router 2 from our local router here, but our subnet on gig 0/2 could not ping that using that source command, then we know we have to address the connectivity issue in that way. We can use all of these commands together as well. You can use any combination of those. So if we say ping 10.1.1.2 source gig 0/2, we can append that size command on there again. Again, this will fail because I'm using a source that it doesn't know about. We can also say, we can add repeat on there. We can add 20, repeat 20 times. We can use all of those command options together. I'm going to break out of that command because I don't actually want it to repeat 20 times. I know they're all going to fail. Another option is to simply go under exec mode as we are here and enter the ping command by itself. If we hit enter, that's going to bring us to a sort of ping wizard, and you're going to be prompted for certain information. First, we're prompted for the protocol that we want to use. By default, that's going to be the IP protocol, but we could say IP version 6 or MPLS, for example. I'll just hit enter and accept the default. Now it asks us for the target IP address. I'll say 10.1.1.2. Next is the repeat count. We see that default value of 5. I'll leave that in place. We see our datagram size, 100 bytes. Remember, we looked at that in the output. 100 bytes is the default size for those ICMP messages. Next is the timeout. Again, we see that default value of 2 seconds. If we want to increase that, we can certainly do so here. And then we're prompted with whether or not we want to use a series of additional commands. The default is no. I'm going to say yes here just so you can see a list of those. You can see that we can choose to use the ingress interface from the remote router as the responding interface if we want to. We can set a specific source address or interface for the ICMP echo on our side. We looked at that. We can set a DSCP value, a type of service value. So if we want to mimic voice over IP traffic, for example, we could tag that with a particular type of service bit. We could set the DF bit, the don't fragment bit. This is the bit within the IP header that determines if a route is allowed to fragment a packet. You could define different data patterns to test for specific faults, such as circuit clocking. And then finally, we have the options to choose loose, strict, record, timestamp, or verbose. Loose specifies the hops that the ping should traverse, while strict will limit those to specified hops. Record will display the IP addresses of the first 9 hops that the packet traverses. The timestamp is going to display the round trip time to the destination for each ping, and the verbose option is automatically selected with any of these options. So I'll just hit enter and just escape out of that. And really, because I chose no on most of those options, it's a simple ping as we would do with the normal command followed by an IP address. So lots and lots of options that's going to let you do a lot of things with a simple command. You can see our results from hitting enter, and we have lots of insight into our connection here. So that's a look at how we can use the basic and extended options found within the ping command.